A warm morning, everyone present here. I'm Usha Rathod from GSSSIETW. I'm from AI and DS department, and my project today is people counting using MCNN and YOLO model. A warm morning to everyone present here. So, everyone would have wondered, like in crowded places, like temples, like Tirupati, everyone of you know, right? And it might be a sports ground where, like, a final IPL match between like the countries which you want to like see and all. Like there, it is very difficult to manage the crowd and all. So, do you guys know how the crowd is managed? By the management people there or something. So if it exits, like the crowd is become too much. So how they handle that crowd, how they manage the requirements they want, if they want more food or they can, if there is any uh, medical emergency, how will they manage it? So there is where my project comes in. It's like it captures the video and or it might be a recorded image. So it counts the number of people there. It detects the people present there. Okay, so here it is like it will give number of people there, and also say if it is high crowd or it is low crowd, it will also give a alert notification that it is a high crowd today. Okay, so that it will be easy for the management people to manage. And then, so I have mainly used two main methodologies. It is like MCNN and YOLO. So MCNN is a multi-column convolutional neural network. It comes under deep learning neural networks. And YOLO is a pre-trained model by for like detecting objects. Okay. Um, so now I'll first show you how the output looks. So if you go to Streamlight, it is also a UI for which makes it easy for us to. It is a pre-trained model. Basically, it makes us easy to like just browse a file which might be an video or image. Here I am taking a video and I'll open it in this. Then, firstly, selecting the mode. I'm selecting MCNN density map first. I've browsed the file, I've taken the file, and then I'll be running it. MCNN density map. Here it is. So what is MCNN basically? It takes the crowded areas. Okay, it checks like where there might be variations. Like in a particular sparse space, it might be like more crowded, and some like here it is more crowded. So it takes those places where it is more, and it counts. So it is multi-column convolutional neural network density map. So here it is taking that those kind of um, data here. The frame number and the count it is giving. The count is for the number of people it is counting, and the frames. What do you mean by frames? If you say um, frames, it is like there will be if a image will have like a one frame. Okay, if it is the video, it is a multiple frames. Okay, so it divides the video into multiple images. That is what is the frames. So here in YOLO you can easily set the number of frames also, so that it is more faster, and it is like not wasting your time, and even it is like it becomes user friendly too, so that you can manually give it. It also give people over time as a graph. So here is the time and the people, like there at this time there will be more people, at this time it is less, like that it is showing a density mapping here as a graph. Okay, now I'll be showing you the YOLO person count. It is for the counting the number of people present there. It is loading the file from the .py. Here it is giving the grounded grids kind of thing. It is calculating the exact location also. It is localizing the people there. We have already given the people data sets, okay, using Carol and the other UCF data sets. Here it is matching those data of person, and it is locating those position also along with the person as an object. It will be seen. So here it found like most people. So it is like frame 485 frame. It has gone through and then calculated the number of people, which is 33. It has given. It is along with the graph again, so that it is easy for us to visualize. Coming here to the coding part. So that was the execution. Now in the combine.py, I have like taken all the files and I have combined it here so that it is like one file will be executing. Now I have imported this streamlit. What is this streamlit? I have already said you like where we have executed this output. It is like basically a UI for us to upload the video or image for us to show the number of people and all. So it is a web-based application for an user. Okay, it is an application. Then OS. What does OS do? It is like basically providing the file path to it. So import OS is for file path. Okay. Then temp file. The temp file, like we have already uploaded a file. Then if we want to rerun the same file, we need not to again like take it and again we have to put it localized in the file. What does temp file do? It is acting like a cache. It will be storing the file in that, so that again when we run the same file, it will be there already. So it is the temp file. And then import cv2. It is opencv. So it is a version 2. Opencv is an library where it is like it will be supporting the image and video processing part. Okay. Then numpy, most of you know, it is for numerical operations. And then pandas, it is like for managing and storing data. And also the graphs we were getting, no, it is basically coming under pandas. Then for page configuration, it is like we are using MCNN and this. So how we are laying out those things and the title what we are giving, all this. And then the sidebars, we have a selection mode. We're switching between the MCNN and the YOLO model. So this is what page configure means. And the common uploader, the uploaded file which we have given, that again loads into that, and this kind of UI, it has been provided by this page configure. And then this is the alert alert configuration part. If you see, it is like if you enable the alerts, it's like will be given a threshold value. Like if it is like beyond 30, it is like medium crowd, it might be 100. If it is 100 and more, then it will be like high crowded, like that we can give it manually. And then if we enable it, then it will show us the alert as it was showing it here in this model, MCNN model. It is showing the alert as high crowd detected to like some number plus, like that. Okay. Now we have added the styling CSS, and the import torch. The import torch is basically for this Streamlight to work. We need this torch. We have also imported TensorFlow, which is provided by Google. It is also a pre-trained model for us to have this object detection and all. We import this TensorFlow into this. So here we have imported TensorFlow. This is the Keras model. It is a pre-trained model which I have taken from Google, just keras.com, and I have uploaded this. We can even manually capture the images and create our own data sets, labeling those and do it. I have taken the already trained model along with the labels, which is Keras model. So this is about combine.py, and then this final.py, it's like how it is different from combine.py. It is like in combine.py, I have integrated all those YOLO and this executing parts, the alert enabling and all. This final.py is basically for adding more features. Like I have included the timestamps and the date and time along with that to show. So there are many similar features in like the what I have explained and combined at PY. Yeah. So our model is basically using MCNN, which is like multi-column convolutional neural network. The project mainly focuses about counting people in the crowded scenes using deep learning models, which is like MCNN. It processes images from multiple data sets to estimate the crowd density and the total crowd in the real world scenarios. I have used Python, TensorFlow, Keras, NumPy, OpenCV, Matplotlib, um, then Argumentation, Pandas, Kaggle Hub. So this is the main application. Um, like we can count the number of people in the crowded areas where the management over there can have an idea or to like make the facilities there or for the emergency maybe or for the like extra food maybe or something like that, so that they have an idea of the crowd. Or it might be if it is like recorded video for the next year, it might be those the previous year was so much, like that. And then further I can add more features, which is like YOLO is already a real time, like simultaneously it gives you the results. Like it is already implemented in like cameras and all. It is like it counts the people over there in traffic and all. It will be there. It will even detect the who is there, and like again if that person has come there, something like that. And then um, I can even add more implementations into that, which is like uh, I can like increase the more size of the image which it can take. So any questions? Yeah, thank you everyone.